So now we're going to look for this next section around enterprise monetization opportunities and strategies. I'm delighted to introduce our moderator for this session, Anton Prenneis, who's the ISV. I don't know what acronym stands for. What's ISV?
Independent Software Developer.
There we go. Business Development Lead for Dell Technologies. So over to you.
Hi, everybody. So I work for Dell EMC. I'm in a relatively new group at Dell. So we're focused on telecom service providers and delivering vertical solutions for telcos. So our group's about over 100 people now, all telco experts and me. So I'm relatively new to the telco space, probably having focused on it for maybe 4 or 5 years. But we do everything from reference architecture-based solutions around NFVI and Edge and things like that, as well as products specific to Edge deployments. And in this particular case, we have a solution with our partner Cardinality around telco data analytics. We have a panel today that is a nice balance. We have somebody from Dell EMC, we have somebody from a partner, and we have a customer. So I'll let everybody jump on stage and introduce themselves. And I guess we can go from left to right. So Brendan, if you want to go first.
Sure. Morning, everybody. I'm Brendan O'Reilly. I'm the CTO of O2 in the UK.
Morning. Hi, I'm Prashant. I'm CTO and co-founder of Cardinality. We're the partner for Dell EMC.
Hi, everybody. Ed Henry, senior scientist and distinguished member of technical staff at Dell.
Okay, great. So the title of this panel is Data Unbounded, Modern Streaming Architecture for 5G. So it's kind of a broad title, but I think I'd like to start with where we've come from and at O2 in particular. And how that's incorporating machine learning today and where we think where that's headed. So I'll let any one of you respond first. But what is it that we're doing with that's being done at O2 today with machine learning, and what are some of the benefits that we're seeing from that?
I can give a quick brief. So we started the journey with Telefonica UK. Almost two and a half years ago, and started as a very simple journey on start looking at solving simple problems. But one of the things what we started looking at outrightly in terms of the design architectures was that each and every data set is important. Don't drop anything, don't leave anything, start collecting 100%, and which is what we started doing. And that led us to a journey where we have reached and delivered what we call network customer experience, which is a KPI, which is per customer information across, looks at almost 300 KPIs, use AI/ML with clustering, and start looking at things where customer feedbacks are taken into account and can be used directly and indirectly into radio optimization, churn, and stuff. So that's the summary of what we're doing. So starting from huge big data set, going down to the level where you can analyze using a small 2 gig data, because that's what machine learning really requires, not the huge 50 billion.
I think the important thing, as Prashant said, is we're using machine learning to help us drive a better, more rounded customer experience. And that's actually where we started at O2. It was very clear that our network metrics were telling us one story and our customer feedback was telling us something different. And the idea behind NCX is, how do you come up with a score that does both? So how does it tell you the health of the network and how customers feel about that at the same time? And working with Cardinality and Dell, we've been able to pull together this NCX score, which, as Prashant said, is down to individual customers, it's down to region, you can even do customer type. And that's really helping change how we deliver network services in the UK. So we've moved away from drop call rates, call success rates, data success rates. And we've moved away from these metrics, and we're now using more customer-focused metrics, which has changed the mindset, not just of the engineering team, but of the whole company, because you can now help marketing make better decisions about how customers will feel about certain aspects of the network and how things will play out. And actually having data at the heart of everything that we do at O2 has become hugely important for us.
It's kind of interesting how you use customer surveys to kind of seed this and initially understand the factors that affect customer satisfaction, and then over time you train machine learning models to be able to recognize that across these 300 plus KPIs. I think that's pretty remarkable. So taking, I guess, a more general look, right? So what are some of the other uses of machine learning today in telco networks, and where do we see that leading? So,
I can take that if you'd like. So I've worked on a broad set of use cases. Generally, there's kind of two approaches I've noticed that telcos are taking. One is how can we enhance our business today, which is the network. And then two, how can we layer services on top of that asset that we have as a giant business? So I've worked on things like I'd seen mentioned earlier, something along the lines of DDoS detection. I've done work in the area of unsupervised learning on DDoS detection. Right now I'm working on robotics use cases that tie in 5G and machine learning and edge and all the different buzzwords that everybody hears these days. But generally, like I had mentioned, most of the time telcos are kind of looking at it as that twofold perspective, which is I have this core business today, how do I enhance that? Which is a lot of like the self-healing network conversations that people have. And then the second side of that is like, what services can I layer on top of that today? And I mean, if you can make a sensor to measure something about reality, I'm sure somebody's going to try to deploy them in some way, shape, or form in the next couple of years.
Yeah, and I think the few things what we have experienced with other operators and Telefonica is radio optimization using AI/ML at the last mile. If you look at where can you really go and mimic what a radio optimization engineer does and automate those things. And as Brendan was mentioning around network customer experience is the idea that call drops, running the network on call drops is kind of old now basically. Yes, it's still important, not saying that, but what a customer really needs to be loyal to an operator is very different what it was 10 years ago. And it could be a very simple thing where we might be predicting products and things which might be helpful for them, giving a Netflix pass to use data between 9 to 11 a.m. might keep that customer loyal with a good experience. So yeah, I think radio optimization, operational intelligence kind of things where self-healing networks, a lot of these things, we're seeing this in the market, and as Ed was mentioning that this is moving towards, as 5G is becoming more and more complicated, it's going to be a very complicated deployment. It's going to take the main stage.
I think the other thing is that using the technology, which we're all so passionate about, to be able to change the way that we run our businesses is really important. So I'll give you an example. You'll get a customer complaint, a VIP customer complaint come in and say, I had this issue in this area at this time. Now, if we go back maybe even 5 years, tradition would have said that we will send out somebody to test that area of the network, see if we can recreate it. That might take a couple of days to send them out there, a couple of days to get the feedback, and all of a sudden it's a week later and your customer is not very happy because it's taken you so long to get back to them. And invariably, it was quite hard to recreate the issue. What we've done with Cardinality is a thing called virtual drive test, which allows us to use network data in almost real time to find issues. And Prashant and the team even managed to get it onto a HoloLens so that you could literally start pulling data out of the air and tracking what was happening on the network in almost real time. I think you got it down to about 15 minutes, didn't you?
Yes, yeah.
So it's a 15-minute delay on what was happening on the network. And that means actually you can go back in time and see what the network looked like at that time in that area and actually pinpoint, with much more accuracy what some of the issues were. So, we see this world looking forward of machine learning, AI, the role that VR and AR will have, but actually some of the use cases that these guys have been doing are doing that today already. And I think if we can continue to evangelize on those things and bring them into the way that we work, actually that's a real demonstration of, sort of drinking your own champagne, as it were.
Can I jump in again?
No. Okay.
How many of you guys have shrunk or bridged the gap between the stakeholders in your business and potential use cases with respect to machine learning? It's a question. You can put your hand up if you want. If not, that's fine. I just wanted to stress the importance. Okay, so we have one. I just wanted to stress the importance of shrinking, or I guess shrinking that gap or building a bridge between the stakeholders of some system it is that you're trying to model. It could be your network, or it could be a new service that you're trying to deploy. Only because what this thing called machine learning is trying to do is automate. You're either automating a decision you're trying to make from a business perspective, or you're trying to automate a system decision in terms of like self-healing networks. But understanding what the stakeholders have in that particular point of automation is almost a necessity, depending on in measuring the success of machine learning applied to any problem, really, and including telco networks.
Yeah. So, there's a lot of talk at this conference, of course, about moving forward to machine learning and AI. When a salesperson talks to a customer, it's very interesting to talk about use cases and the business value that can be derived from those use cases. And in all of this forward-looking kind of talk, we tend to lose focus that plumbing is important, right? And there could be an underlying assumption that most of the problems with ETL have been solved 5-10 years ago, but in reality, it's still a challenge. And I don't know if any of you would like to talk about the importance of ETL and what that means in the real world
Yeah, I can make a few comments. So I think someone in the morning from Verizon team was presenting this.
Yeah.
I was quite glad to see that there was presentation which says data cleansing and stuff. And you're right, at every time we present, we meet CXO level people and middle managers. Everyone is really mesmerized with what machine learning models are you going to use, how, and you see big companies, small companies getting these machine learning models running on Jupyter notebooks and things, but taking that to run in a network with 500,000 cells, with 30 million, 50 million customer base, constantly doing machine learning APIs on that, it's very different than developing a model on a laptop and trying running it with a really nice dashboard. So you're right. So one of the things the challenges we faced quite early on was a really simple problem that mobile networks are still built in a very simple way that you have user plane, control plane running in two different planes altogether, and you have to combine them, mix them together. And I haven't come across a single supply network in the last 10 years now. Every network has got multiple suppliers. You have Nokia, Ericsson, Huawei, Netscout, Empirix, all these technologies floating around with upgrades and things happening. These are the realities of what an operationalized machine learning process has to go through. So this is where we have created that scaled stack. And we have solved this problem in a very, very simple way that let's start looking at how Google does it. The good thing with Google is they write their own software. They don't have to deal with all these versions and things. They don't have to deal with 3GPP standards. And then how can you open up the data? Someone was talking about democratizing the data in Verizon team. And we've got roughly 200 users of the platform within Telefonica. And the reason for that is the last mile is not controlled by anyone. If the last mile is Jupyter Notebook or a Tableau dashboard or, I don't know, like any dashboarding system, machine learning, so be it. It's fine. As long as you're harnessing the power and opening up the data to everyone, giving it to everyone in the team. So yeah, it's that architecture, and one of the things I think which has helped massively as well is the cloud native bit. So from day one, we were very bullish on Dockers and containers and Kubernetes, which has helped us to scale massively. Our stack in Telefonica is running on roughly 350 servers, with Hadoop as one of the biggest deployment in Europe, our stack running on 100 servers. And the reason why this is because we're purely cloud native, and it works. The whole story, what the cloud companies are selling, from a scalability perspective, it works. You can plug in models, you can open up the stack.
And I think what this work made us do in O2 was look at the architecture of our network and how we were set up for the future. And as Prashant has said, the fact that we were quite bullish on ensuring that we use cloud actually came from the understanding that everybody now has, that pushing stuff out to the cloud is a much more efficient way of delivering services as you grow and as you scale. But interestingly enough, you have to pick and choose what you are going to put in the cloud and what you don't. And we've got this sort of hybrid model that Prashant's quite happy with, where we sort of keep the brains on-prem and everything else goes to the cloud, and that's really worked for us. But we've taken a similar approach to our network. So as much as we're pushing towards the cloud, there are some things that you are going to want to keep on-prem for various different reasons, and that's okay. You have to understand how your network is made up to be able to get the most out of it, and this project in particular has helped us on that journey.
So I'll go back to the ETL specific portion of the question. It's largely kind of use case driven. Some of the robotics use cases, everybody here has kind of got a networking background, and there's kind of a heuristic or rule of thumb. Keep complexity at the edge, right? So make the core really fat and dumb and keep all the complexity and intelligence at the edge. So when you talk about ETL, we're talking about collecting data in some way, shape, or form. I'll use a concrete example of video camera or image data from the edge. It may be that you want to pre-process the data at the edge depending on how many different points of collection that you have, because you don't have the bandwidth to be able, or the compute bandwidth, if you will, to be able to post-process those images after they've been collected. So some of the use cases that I've explored have been on the order of, like, I have a little small rover that I have driving around my house right now. It's got 4 8-megapixel cameras on it, and I'm generating about 1.2 gigabytes of data per minute. So when you talk about collecting that size or that amount of data and then post-processing it after it's been collected, it might make sense to pre-process it on the actual rover before you ship it back to wherever it needs to go. So depending on what it is you're trying to accomplish from a use case perspective, you can start to gauge where that kind of computation should take place.
So, on the point of data, training big data models, machine learning models rather, requires a lot of data. I don't think it's realistic to say you can train a machine learning model effectively on a subset of data, right? So, would any of you be, have an opinion on how to train machine learning models before you go into production? Where do you get access to this data? What are some of these challenges? What are some of the challenges there? And I think it becomes more of a challenge, too, as we move to 5G, right? So there isn't a whole lot of, by way of 5G data sets necessarily available.
I think one of the things I've seen recently is the terms KPI and KQI are not cool anymore. So because, well, you're doing KPI, so that must be doing something wrong, because you're not doing AIML. The reality of it is the journey of AIML still starts with old school statistics. You still do averages, still do CDFs, and you still find out, because, so we are ingesting roughly north of 50 billion rows in a day. Mm-hmm. And to reach the point where we're creating 300, 350 KPIs per customer, and then we are predicting what's going to happen to the customer experience and behavior, these are two different scales. So what I'm trying to get to is that the journey of machine learning still starts in the old school dashboards and averages to figure out what machine learning patterns, what machine learning models will be implemented to it. And then once you figure out which particular methodology you're using, let's say, k-mean clusters, and in k-mean clusters you're figuring out that actually 50% of the data is useless because it's creating more noise in my model. You can start removing that in the plumbing side of it. And going back on the training side of it is that basically paves the way of how you start bringing in data which is not distorting your learning, but also not creating what I call the right AI model. It goes back to the day of that you never ask a programmer to go and test his own program, because they will always test the right thing. So this is the challenge which always comes in. If you remove the data, you might train a model which might miss the real conditions. Mm-hmm. This is time consuming, and this is why one of the things what we always I think patience is of essence in this thing, that if it takes a machine learning model to 3 months to learn, it will take that much time. It can't be done within 15 days.
So I think this is actually a two-part question in disguise. The first part is the people man-hours. This isn't software engineering. You can't go to your data science team and ask them the computational complexity on a particular algorithm or model that they're testing, right? They're going to have to go and find a data set that's representative of whatever it is you're trying to do, and then test the model and tell you whether or not, according to some performance measure, that worked. And then the second half of that is talking about, like, how much data do you need to capture the variance of a system, right? And that's an open question entirely. So what a lot of people don't talk about, and it's kind of a hidden implicit assumption that everybody kind of ignores right now, is this idea of what's called stationarity. And most of the methods that we use in the world of machine learning today assume the world doesn't change, and that's why we have to do this process called retraining a model or measuring when change points happen in production. So depending on how much data, like if you're asking the question of how much data you need to capture a phenomenon, it's an open question, and that leads back into that kind of recursive cycle of doing this hypothesis exploration and measuring whether or not it provides value to your business.
Yeah, I think one of the reasons why it's so important with 5G sort of firmly on the horizon is if you think about the sort of triangle of hope that we've been sold, which is, you know, ultra reliable, low latency, massive IoT, and enhanced mobile broadband. In that massive IoT space, we will have millions of devices connected to our networks that can never tell us whether they're happy or not. And understanding the happiness of that device is really, really important in the world that we're moving into. And NCX was one of our attempts at being able to do that. So if we can predict how happy customers are and get their feedback and then hone the model to be able to tell us whether we're right or not, then in the future when we have devices, we'll be able to work out how happy they are with the network and whether they're getting what they need. So I think on the edge of sort of a big explosion in 5G across the world, you know, data becomes much more important, but how we process it and how we use it and what we take from it will define how we run our networks in the future, much more so than they do today.
Yeah. Yeah, and the edge in particular is it opens up a number of different adjacent opportunities for telcos to get into. You know, IoT is an industry vertical. It's kind of a revolution in network computing. What are some of the specific areas, if you have some in mind, that you think you would be, you know, looking to expand into? You know, as you, I guess, evolve from being a communication service provider to being more of a general service provider or a digital service provider, or whatever term you want to use. So, is it utilities? Is it what are some of the IoT opportunities that you think are? It's more of a market question.
Yeah, I think you see lots. I think you see lots of opportunity, and you know what we've done in the UK. We're working with Bosch and Mazak on some 5G manufacturing use cases around augmented reality for field maintenance. We're part of the Millbrook Consortium, which is looking at the role that connectivity will play in autonomous vehicles of the future. But I don't think that there is an industry or a sector that isn't ready to be transformed by 5G, but 5G is just one of these big tools and big levers that we can pull in sort of digitizing, you know, especially in the UK. We talk about the value that 5G will bring for UK PLC, and if you look at the utility industry, there's a massive role that data and 5G can play in there. If you look at the transportation industry, the same, construction industry, manufacturing. So I don't think there is any sector that isn't ready to be transformed. The challenge, I suppose, is can you get the right collection of partners in a room to be able to do it? Because there is no one partner who can do it on their own. Collaboration is such an important part of 5G because, you know, we couldn't have got where we were today if it hadn't been for working with Cardinality and Dell. We couldn't do it by ourselves. If you look at some of the 5G use cases for tomorrow, if you're going to transform the utility industry, data is such an important part. The infrastructure and the platform are important. The service wrap you're going to put around it, plus the utility themselves. So collaboration, I think, is probably the biggest tool we have and the biggest lever we need to pull to make 5G a reality.
Yeah. So I suppose you see operators as more of a platform kind of thing, which is enabling an ecosystem thinking for lots of people to come in, deploy services, use the services, multiple things. The idea of, I think, open APIs and things starts coming in and starts getting transformed multiple. But operator being transformed as a platform, because that's what I think I'm reading between the lines of what Brendan's mentioning, that because Telefonica becomes more of a platform. It's like AWS. It's you bring in, you give X kind of services. The services can be data services, it could be network services, doesn't matter, but as long as you can subscribe to them and work closely, and it's an ecosystem.
I think it's the idea that in the past, someone would come in and sell you something and you'd buy it. I think that sort of moves away in a 5G era as you get a group of people together to coalesce around a problem or a challenge. you actually work out what the solution is, and then you work out the role that everyone's going to play in that afterwards. And I think that whole ideation process is going to be so important as we move into more complex challenges. And the idea that, you know, an O2 or a Dell or anybody can come in and say, I've got the answer to that, I think it is in the past. Actually, we can all play a role in whatever the challenge is and whatever the solution is. But you've got to work out how you're going to do it first, and then work out who's best placed to play each of those roles. And that's something we're seeing more and more, especially in big enterprise businesses, where there isn't that sort of one-stop shop anymore. And being able to work with a number of partners and collaborate around a problem is so important as we move into the future.
So there was an economist, I think it was mid to late 1800s, his name is Jevons, and he has this theory that he came up with. It's called Jevons Paradox, in that no matter how much of a resources we create, we're going to consume it. He saw this with coal consumption in the late 1800s. So we saw this last push in telco providers, this thing called 4G and other carrier services, and we've kind of hit that upper bound in terms of Jevons Paradox, if you will. We've created a resource and now we've consumed all of it. 5G is the next step to move, again, push that kind of needle forward a bit. So there's a lot of services that companies may be able to want to deploy on top of something like 5G that offers faster throughput and lower latency and more bandwidth. So the fact that we're moving, again, toward opening the floodgates a little bit more will enable a lot of businesses to be able to move forward.
Yeah. And what's your feeling on where we need to go from an infrastructure standpoint and from a software standpoint as we move more intelligence to the edge? I mean, do you feel like it's a simple problem of just moving compute to where the data is, or is there work that needs to be done in order for us to achieve, you know, true, I guess, real-time analytics, real-time intelligence?
I think the challenge I see is no matter where you move it, you have to retain the trust of your customers. So if you're going to put it more towards the edge, you've got to make sure it's a secure edge where you treat customers' data, you know, in a very secure way. So I do see services moving more to the edge, and if you look at where we're going with mobile edge computing and the role that will play in, you know, a lot of gaming services, etc., I can see us doing that. But for me, I go back to if you're gonna be the custodian of somebody's data, no matter where you put it, security absolutely has to be at the top end of your list of things to make sure happens. So I think for different use cases, it will be they'll come about in a slightly different way. But security absolutely must be at the forefront of wherever we put the data. Yeah.
Yeah, I think, I mean, for me, I always see that this is going to be a transition, evolution towards the hub and spoke model kind of thing. Multiple hubs in a spoke model interconnected with things using interconnected fiber optics, high-speed networks. So the edge can actually exchange data with other edges, but it can also go back to the hub model as well. I think the challenge here is there is a lot of evangelistic thinking which is happening right now, which is what any industry goes through. AI, ML industry has gone through, search industry has gone through, anything. So I think it'll be a few years before the real patterns and the things will come out, but you could see the real deployments happening in the market, as Brendan was mentioning around maps and gaming. So if you have a gameplay and a frame to be delivered, you don't have to deliver it from California. It can be done locally somewhere within London itself or an edge tower. The same thing with the maps and lots of these problems. The other thing also comes in is not every problem can be divided and can be split out, because a lot of problems can only be done centrally. Mm-hmm. So it's dependent, from my perspective, it's dependent on the amount of investment which has already gone into data centers. And Kubernetes is playing a real big role in this, and we see this as a big plus point for us, because we've core containerized platform, and containers are becoming the de facto. My assumption is there are quite a few virtualization companies who are worried, and they have done a lot of acquisitions and stuff to migrate towards that side of the world. But they're still far away from the reality, because there's a blue sky thinking and there's a real world. Yeah. But yeah, I mean, it depends on the problem. It depends on the investment cycles, the ROI, which is already, data centers are already huge. Then there is a cloud story bringing in. So there are lots of factors which starts coming into play, and it probably will like any technology thing transitions, it takes this Gartner hype cycle curve thing. So it's going up the hype cycle. It will become reality. It will become uncool in 5 years' time because now it has to be done.
Yeah.
So we'll see. But yeah, there are a few things which will drive it.
Yeah, I tend to think about like computation in general, and it seems to follow this kind of bouncing model that we have to describe the universe, where the universe expands and collapses, and we tend to move compute around in that respect as well. Depending from a machine learning perspective, what does that mean? Where do we park the computation? To what Anton had alluded to what Prashant said, it depends. And the reason why is because if you're using non-parametric models, which means like k-nearest neighbors or k-means, something where the parameter space can grow with the data set that you have, it has to be centrally located. There's no way to actually break that model up over distributed computational platforms. So all of your data needs to be centrally located and needs to be evaluated at every cycle for evaluation of the model. It's called a lazy learner. When you start talking about these things like deep learning or neural networks in general, they're what are called parametric models. So you could potentially deploy that at the edge or train it at the edge or continually train that model in some way, shape, or form as you collect data. So it just depends on what problem are you trying to solve and what constraints are you operating in from an engineering and data science perspective.
Great. Well, so I know we have maybe 2 minutes left, so maybe we have time for 1 or 2 questions. Yeah.
Any questions from the audience?
This is Mallikarjuna Valluri from US Cellular. Quick question. The title says streaming architecture for 5G. So what does that mean from the terms we are hearing, the service-based architecture versus this streaming architecture? Are we thinking more about the data, or can you clarify streaming architectures versus service-based architecture?
So we see everything as a flowing data, and the question I always ask every time the question of service comes down is, and I've worked in the past with the SOC projects, and we were doing this with Deutsche Telekom at the time, and we did this a general review, and we said define service. And the question always comes, and this is back in 2009, and at the time, for some people SMS is a service, for some people voice is a service, some people voice over LTE is a service, some people Facebook is a service. Facebook streaming is another service. So what I'm trying to get to is that service is just a way how you circle out the information at the very end. That doesn't mean your plumbing should start narrating what service you want to start looking at the end. Because what the service and the core, what you're deploying right now, the killer app for 5G is not there yet, but 5G is still being delivered on the idea of build and they will come, which is what has happened in 4G. That 4G is starting to choke out basically because people are using more data. So what I'm trying to get to is that those architectural views shouldn't be defined, the streaming architectural view shouldn't be defined at what service you want to learn about. It should be defined as is, to be able to give that view of perspective of each and every end user. If it's a marketing person, they can get a marketing perspective of that service, whatever that service comes out for 5G.
This is Mario again, US Cellular. Got a question, I guess, about vision. You talk about 5G, and recently I ran into this new release, release 16, 3GPP. I think they introduced the network data analytics function. Just want to know if you guys think about it, how you guys are going to integrate that in Telefonica O2. Are you guys? One of the big questions I have is this something that you guys are thinking building it or purchasing, or how this will play with the solution that you guys have in place already?
I can. No. So I think we are thinking about it and where we've got to, and I think Prashant described it quite well, is we see data as a constant stream, and it's about where and who will dip in and out of that stream as to what they will see. So the approach that we're taking to data is that, and the person this morning talked about the democratization of data, and that's absolutely right. But you want data to be democratized, but you want to be very sure about who's going to take out what and where, and that's why this constant stream is so important to us. So, we have marketing people who can access this data now to answer questions that they have about campaigns that they want to run. They don't have to access all of it. They don't have to be able to pull out or create their own algorithms to be able to do it, but they can interrogate the data in the way that works for them. We have the same from a finance point of view. We have the same from a network point of view. Operations look at data in a very different way to planning, as an example. So while we are looking at next-gen data from a standards point of view, we're taking a step back and saying, actually, what is the role that data will play in our future organisation? Do we want to be driven to make decisions based purely on data in a way that we haven't been before? And if we do, what's the architecture that we build around it? And this journey is part of that. And as Prashant said, we started it 2.5 years ago. Because we saw that if we were to get the most out of our network, the very best that we could out of it, the decisions that we made had to be right all of the time. And the best way of doing that is basing them on data that is clean, clear, and then you're decisive about those actions. So that's the role that we see data playing in what we do at O2.
And I think just one more point on the 5G bit which you were asking about. So the whole stack is moving towards containerized stacks. If you have a containerized control plane, if you have containerized, so this is why the point I was trying to make earlier is that we have heavily invested into Kubernetes and containerized platforms. So whether your container sits on our Kubernetes stack or Ericsson's Kubernetes stack, which is running the control plane and actually doing a lot of localized machine learning, going back to Ed's point, whether you're doing things localized and then bringing some data, that's a design pattern. That's the way it shouldn't be hard-coded. Gone are the days where we will go and ETL the data, dump it in a Hadoop cluster, do something with it, and then wait for something brilliant to come out after 1 year. So these design patterns are very fluid with orchestration engines in play, with containerization in play, opening infrastructures and things in 5G. That will help. I think that will drive it. But you have to always look at one thing is, and this comes from the old school PM system, you won't ask a child to go and mark their own homework. So your analytics always has to be very independent. Because most of the time, if you ask a supplier to go and say, hey, how's this thing performing in a network? And they say, oh, it's brilliant. We are giving you, everything is green. But the reality of the service might be different. So it's just a perspective that your analytics has to be independent across all of the suppliers.
From a protocol perspective, too, you had mentioned that they added maybe a header or something that carries information about the network in some way, shape, or form. Machine learning is leaning on this idea of what's called a representation. And representation means, give you a concrete example, pixel intensity values inside of images. That's a representation of the objects that are in that image. When you collect data on a network today, whether it be like SNMP or log data or syslog data, those are all considered representations. So it's a proxy for what is the current state of the infrastructure. And I think what's interesting from the perspective of what's going on in the area of adding protocols to standards to be able to carry that information is how modular is that piece of metadata that you can slot in and out of that header, just as an example. Only because it might be that over the next 4 or 5 years, as research progresses, applying machine learning to interesting networking infrastructure or infrastructure problems in general, we might want to add a new representation in or slot a new representation into that header. So I'm glad to see that they're adding different ways for us to normalize, if you will, the ways in which we can collect data about infrastructure in general.
I'm going to use my role as chair just to ask a question, Ed. I want to build on something you said before. Question I get asked a lot, actually, when I'm meeting with customers, how much data do you need, right, to make an AI algorithm correct? And as you said, I completely agree with you. But the question is, though, if you think about it, 90% of the world's data has been created in the past 2 years. But only 1% of that is analysed and utilised. So people like Brendan, who's looking at data across his network, how do you decide how much data do you keep and which ones do you have to dump? And does data have a half-life? Because if you think about it, only 1% of that data now is analysed and utilised. Now, it'd be great to get that to 20, 25%. I'm sure we'll get much better insights. But a lot of CTIOs now have this urge to save every single piece of data that comes across their network. The challenge is it gets very, very expensive. It doesn't matter if you start going off into Microsoft Azure or wherever. The fact is the cost of that data is going to rise exponentially. So how do you decide what data to keep, what to use, and then does it have a half-life to start dumping it out?
That's a great question. So how much is a heuristic? And what I mean by that is it's a rule of thumb, like a lot of different things. So when you're in the realm of computer vision, a lot of people will quote this number, 10,000 images for a classifier, right? That's a rough estimate. I have hours and hours of video from that little rover I told you about, and I still can't figure out how to drive through my house, right? And you're talking about on the order of hundreds of thousands of images. So it depends on the problem that you're trying to solve. Notably, though, depending on how much data you want to, like, think about it like this. The world is generating data around us all day long. You and I talking to each other are generating data. So the amount of data that we can collect is nearly infinite. So what can we do with all of that? Can we collect some subset of all of this data around us to be able to do something interesting using this methodology called machine learning? That's an open question. And what I mean by that is pick a domain, and anything measurable today, you can likely capture some sort of sufficient statistics about it. The information flowing through this microphone right now, you and I could find a mean and variance of the distribution of intensity values streaming through that board. The idea is it depends on the problem that you're trying to solve, and it's largely exploratory, depending on how much data you need to capture the properties of that system that you're trying to capture. I try to tell people all the time, this is fundamentally different than software engineering. It's an exploratory research kind of esque area of endeavor, if you will.
And I think that exploratory is the really interesting word, because if we only look at data looking backwards, then we won't see any insight moving forward. So in answer to the question, what do you dump? Actually, one of the debates Prashant and I had right at the start was actually we don't really want to dump anything, because neither of us knew whether it was required. So I think there's an extent that you can start driving into your subsets once you coalesce around a problem that you want to solve, and you say, right, this is the data I need for this challenge or this solution. But actually, for the next one, it could be a completely different data set. And I think the word exploratory and forward-looking view of what it is that you're trying to solve is so important in that.
Yeah, and I think the point you made around it's very different from software engineering, because the problem with automation is people still look at it, oh, I'm going to build a web page and I'm going to do this. Machine learning is so different from that. In NCX use case, for example, just to give you this in context, is we ingest up to 50 billion rows, but when the machine learning works, it becomes a 1 or 2 gig file. So we go from 40, 50 terabytes to a 2 gig file, which is basically a really simple table of feature set table of 30 million customers, 300 KPIs, but it has a representation of what customers are experiencing. So, and that can be run on your laptop. But can I start from a laptop? No. But I still have to start the journey from start. And by the way, I have tried to trace that, what you mentioned, that the 80 to 90% of the data has been, I have heard that in so many documentaries. I try to trace it, who said it.
IBM.
Probably. I think IBM and Cisco. And as Ed was saying, data has always been generated. It's just that we had the means, the hardware, and the software to collect it, and we can go and analyze it. Big data and the insurance companies have been the oldest big data companies in the world. Army and defense has been using big data for ages. Algorithms have been there. It's just that we can collect it more. But yeah, I hope that answers the question.
I think the answer is nobody quite knows what data they need. I think that's Anton, do you have a closing remark or anything you want to end with?
No, I just think this was really good. So, Brendan, Prashant, Ed, thank you very much. Thank you all for...
Huge round of applause. Thank you very much.